All right, in this video, we're going to talk about the intermediate value theorem, and we will refer that to IVT for short. But on the AP exam, I don't want you to ever write IVT. I want you to write out the intermediate value theorem. All right, so that's our first big theorem, and the main idea behind it is pretty intuitive. It's going to make sense. It might look a little complicated on all the stuff you have to write on this, but I think it makes sense if you just like work your way and think about it. So let's look at this example, and I think you'll feel pretty comfortable. It says, suppose you're 4 feet 6 inches tall when you're 10 years old, and now you're 5'7". So you're 5 feet 7 inches tall. The question is, was there ever a time that you were exactly 5 feet tall? And when would that time have occurred? All right, so I think it's pretty intuitive. You all say yes, right? We don't know when that happened, but we know that it happened. We know if you start out at 4'6" and you just grow, you don't magically like skip like 5 feet tall and go straight to 5 feet 7. It's a gradual change. It changes. So if I was drawing it when you're 10 years old, and now how old are y'all? Like 17, 18, 17, and then now you're this tall. So at 10 years old, you're 4'6", and now you are 5'7". There was no jump, right? You don't go from at 10 years old, I might have said 10 feet tall, but you're 4'6" at 10. You don't get bigger and all of a sudden just jump up to a bigger amount, right? And then magically now you are 5 feet 7. So it's a gradual time. At some point, like if I make a y-axis here, this was 4'6". This is 5'7". At some point, we don't know when it happened, but we know at some point you were 5 foot tall, right? All right, this is called an existence theorem. We don't know when it happened, but we know it happened. So that's the whole concept behind intermediate value theorem. Now let's kind of like math it up and make it all formal. So the big condition is f has to be continuous. So if f is continuous on the closed interval, it has to be at the endpoints also, right? The open interval would be from like a to b, not including a and b. But those brackets means a and b are included. So at 17, it can't have, like it has to be at the endpoint too. Let me draw. So you're 10 years old, here you are. You're getting taller, and then you're here. It's not like all of a sudden magically you jump up. That's why it's saying it has to be continuous even at the very ends. So the way I remember that is continuous starts with the letter C, closed starts with the letter C. So it has to be continuous on the closed interval AB, where the y values, f of A can't equal f of B. So it has to have changed, right? You can't start at 4'6" and then end at 4'6", and sometime we can't necessarily say you got taller or shorter in that time. So if f is continuous in the closed interval AB, where the y values at the endpoints are not equal to each other, and k is some number, so k is a y number, an output, and k is some number in between. So in this case, our k would have been 5 feet. Our a was 4'6", our b was 5'7", our k is 5 feet. So k is in between those endpoints. There has to be at least one number c, so that's the time, that's the time when you were 5 feet tall. All right, so intermediate, okay, so it said f of c equals k. The intermediate means between. That's the big idea. So if the x's are in between and the y's are in between, we know there has to be the x that gives you that. All right, the IVT is about showing that a point exists between two values. So we're showing that if you started at 4'6", you ended at 5'7", at some point, we don't know when, but sometime in between there, you were 5 feet tall. That has to exist at some point. All right, the IVT is called an existence theorem. We will learn three total. We'll also talk about the mean value theorem and the extreme value theorem throughout the class. But right now, just the intermediate value theorem. When using a theorem, we must first show that the conditions are met. Condition 1, the function must be continuous on the given closed interval. And we'll practice how to say that. Condition 2, the y value that we want must be between the y values of the endpoints. So AP problems rarely explicitly ask you to use IVT, but you just have to recognize the wording on when you need to use it. It'll say like, must there be a time? Or can we guarantee? Show that there exists. Does a value exist? So those are the key phrases that tell you, oh, it's the intermediate value theorem. That's what I'm supposed to be doing. All right, to apply the intermediate value theorem, we first have to find the function values. Function values, let me write that better. That's not any better. The function values on the given interval by plugging in the values into the function. So you're given the endpoints, the x's, plug those in, find the y's that you're given, show that the requested y value is between, so just say it, between the two y values of the endpoints. Make sure the function is continuous. Usually the problem will say, the function is continuous, and then you just repeat it. Or if it's a polynomial, we know polynomials are continuous, so we would just say, since it's a polynomial, it's continuous on the closed interval. Okay, then invoke the IVT by using the following conclusion. Since the f of x is continuous on the interval blah, 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 the intermediate value theorem guarantees that. And then you reword the question. All right, so I made a little sentence stem that might help you at first. If you want to just think about it, where'd example 1 go? Oh, here's example 1. If you want to just write it out, and just as long as you're saying all the stuff, that helps. But I found out last year this was kind of helpful to have these little sentence stems in there to help you until you get better at it. All right, so example 1 says the function f of x is continuous with selected values in the table. Is there a value, there's that phrase, is there a value c in between 1 and 7? So is there an x value in between the x values that were given such that f of c has to be 0? And then justify your answer. All right, one of the biggest things, and it's the easiest thing, is just writing yes or no. Is there a value? Yes. Or is there not a value? No. And then write your reason. You can't just start saying the function's continuous. Make sure you say yes or answer the question. All right, so what do we need to do? I wish I wouldn't have written this at all, but it's there, so I guess we have to kind of use it. All right, the first thing we need to recognize is that the y values at the endpoints are between -2 and 6. So is there a value c? Is there an x number where the y value has to be 0? Well, yes, because 0 is in between 6 and -2. So our y value that we're looking for is in between the y values of the endpoints. So there has to be a c number in there somewhere. And then so we say, yes, the function f of x is continuous on the interval, and I'm going to write the closed interval, 1 to 7, so the x numbers. And f of 1 is equal to -2. So we want to write that first. We want to write what the endpoint values are. And f of the right endpoint, f of 7 is equal to 6. Okay, just say that part. Say that it's continuous, and then write out what the endpoints are, or the y values are at the endpoints. Then say the intermediate value theorem guarantees, I like that word guarantees, that there is a value c with 1, well, I'm going to say c is in between 1 and 7, because that's what the question was saying, so I'm rewording the question. such that f of c is equal to 0, because f of c is in between, I could say f of 1 is equal to negative 2, and f of 7, 6. So I could just say it's in between negative 2 and 6. You wouldn't, and if since you've already wrote it up here, so you could just write since f of c is in between 1, not 1, the y value, between negative 2 and 6. So you don't have to write it one way. On the AP test in May, you don't have to like remember this sentence stem. This is just to help you practice for a minute until we get a little bit better. But as long as you're saying all the right pieces, it doesn't have to be word for word the same thing. All right, so maybe the next one we will cross it out and then just see how we can write other things. All right, so use the intermediate value theorem to show that g of x is equal to x cubed plus 2x minus 1 has a 0 in the interval 0 to 1. So to have a 0 means g of x has to equal 0, right? That's the 0, so the x number. So I might replace that x with a c. I can replace it with anything. But I'm going to cross this out because I don't like the way it says it anyway. Because it says use the intermediate value theorem to show that, show that this function has a 0 on the interval. All right, so I might just start out by writing g of 0, I'm plugging in the left endpoint, is equal to, 0 plus 0 minus 1 is negative 1. And g of 1 is equal to 1 plus 2 minus 1. Okay, that's hard. 3 minus, I think it's 2. All right, so does the function have to have a 0 in the interval? Yes, because 0 is in between those y values. All right, so how could we write this? I could say since g of x is continuous, I could say a continuous polynomial. But if you just say it with some confidence, they'll give you credit. It's continuous on the closed interval 0 to 1. And I could say g of 0 is equal to negative 1. And g of 1 is equal to 2. I could say comma. The AP readers are not going to take off because your grammar. So you can make it one big, long, run-on sentence as long as you say all the right stuff. So since the function is continuous and the endpoint function values are negative 1 and 2, the intermediate value theorem guarantees there is a value, and we can say C such that I'm going to say C is in between my x values, my endpoints. Go back and look at something real quick. I lost my train of thought. Such that the value C such that, C is in between the x's, C is in the interval, and g of C is equal to 0. That's what it means to be a 0. And I'm going to say since, this is a terrible run-on sentence, or I could just say and. Again, it doesn't have to be word for word the same thing as long as you're saying all the stuff. So whatever feels right to you, whatever makes sense in your brain, word it your way. Don't try to force it into the way I say it because it might not stick with you. Do the way it makes sense to you. And g of, I'm just going to write this one more time. So that 0, that's this 0, is in between the function values at the endpoints. That should give you full credit. If you write it some way differently, if you're doing this because you're watching this because you missed class or just needed more time with it, if you want to ask me how you write it, if it would be full credit, I'll give you my best opinion of I think, because I don't know anything. All right, example 3. Last one. The function x, or h of x and k of x are continuous. Okay, it says that. It's continuous. Selected values are given. Let m be the function defined that m of x is equal to, excuse me, k of h of x. Can you guarantee there's a value c in between the x's such that m of c equals 4? All right, I don't want this sentence then. If you liked it, great. But if not, I want you to do it like whatever makes sense to you. Write it how you want to write it. All right, so first of all, we need to find out what is m of 1. Well, m of 1 is going to be equal to k of h of 1. So I got to find out what that is. H of 1 is 5, and k of 5 is 7. Okay, m of 9 is equal to k of h of 9. Because this one, you gotta see, how is m defined? M is defined as a composition of two other functions. A little tricky. It's kind of fun though. H of 9 is 2, so this is k of 2. K of 2 is 1. All right, so even though these are backwards, just you can kind of keep it straight in your head. All right, so m of 7 is 1, m of 1 is 7, m of 9 is 1. What's the question asking for? 4? Yeah, because 4 is in between the y value 4 is in between the y values of 7 and 1. So yeah, we know the IVT guarantees there is going to be some time, some value of x in between 1 and 9 that would give you m of whatever equal to 4. All right, so give you a reason for your answer. Can you guarantee? Yes. I'm going to say since k of x and h of x are continuous on the closed interval 1, 9, so is m of x. And m of 1 is equal to 7, and m of 9 is equal to 1. So I'm stating that the function's continuous. I'm writing the y values at the endpoints, and then now we can invoke the IVT, the intermediate value theorem. Guarantees, and what does it guarantee again? It guarantees there's a C number there. So go back to that problem about the height. If you start out at 4'6" and you end at 5'7", is there some time in between 10 years old and your current age that you were 5 feet? Yes. So just write that out. So the intermediate value theorem guarantees there is a C value. Yep, there is a C value in between 1 and 9, and I could write it like that, all as 1. Last time I made it longer. Such that m of c is equal to 4 since m of 9 is less than 4, which is less than m of 1. And since we already wrote out up here what the m values were, I don't have to write them again. I could write m of 9 equals 1, which is less than 4, which is less than m of 1, which is 7. If that makes you feel better, just write the whole thing out, but you don't have to. All right, that's it. If you have any questions, if you're watching this for the first time, next time in class, ask me.